MiniMax H3 now has a mature turbo acceleration solution. With only 4 sampling steps, we can generate a 5-second video in about 2 minutes. That sounds almost unbelievable, and there's more than one acceleration LoRa available. For this video, I tested 3 different options. The first comes from Kijai, the second from larryvrh, and the third from drbaph. We'll use the same ComfyUI workflow and keep the prompt, sampling steps, test scene, and seed as consistent as possible. Then we'll compare the results and see which of these 3 LoRas is the best choice. So why test these 3? There are 3 main reasons. First, Kijai regularly organizes and adapts different models for ComfyUI. His models and workflows are relatively easy to find, which makes them easy to reproduce, and the quality is usually very high. The second option comes from larryvrh. I included it because MiniMax officially recommended it on X. It also provides several versions, including VE5 Fu Liu Bai and VI Fu Ba Bai Wu Shi. The third LoRa comes from drbaph. It also offers multiple versions, including one specifically optimized for pruned models. That's important because the ComfyUI model most of us use is the pruned INT8 version. So we need to test all 3 LoRas and see how they actually perform. For easier testing, I've also built the workflow on RunningHub. In the ComfyUI space, RunningHub is a great online working platform because whenever a new model or extension comes out, it usually adds support very quickly. RunningHub also provides an online community for ComfyUI creators, where you can find plenty of creative inspiration and example workflows. Let's start with the first workflow. I'm using image to video here. Keep in mind that all the LoRas we're discussing are designed for the FL2VA model, so they don't work with reference-based generation. You'll notice that the overall structure of this accelerated workflow is almost identical to the official workflow. The main changes are concentrated in 4 areas. First, we're using the pruned INT8 model as the base model. After that, we load a Turbo LoRA. You can simply choose one of the 3 LoRas we're testing today. We'll analyze their results in detail shortly. I've also enabled sajitention. The most important change, however, is in the sampling section. Since this is a 4-step Turbo LoRa, I've set the number of sampling steps to 4. I've also changed the sampler. The official workflow uses rsimultiste, but I think that's too slow for an acceleration workflow. So I changed it to Euler. Another major change is that I replaced basic guider with CFG guider. When using a Turbo LoRa, we normally set CFG to 1.0. Basic guider doesn't allow us to configure CFG, which is why I switched to CFG guider. We also need negative conditioning, but this part of the workflow only outputs positive conditioning. So I send that output through a ConditioningZeroOut node to create the negative conditioning. I want to make one thing clear. This is a workflow structure I developed through my own testing, so I'm only presenting it as a reference. That said, the generated results are genuinely quite good. The test video is about 5 seconds long at 24 frames per second, giving us roughly 120 frames. On an RTX 4090 with 24 GB of VRAM, the original image-to-video workflow took around 8 minutes and 29 seconds. After acceleration, the generation time dropped to 1 minute and 38 seconds. You can do the math yourself. The difference is substantial. All 3 LoRas provide roughly the same acceleration because they're fundamentally 4-step turbo models. The real difference lies in video quality. So next, let's compare them side by side and decide which one to use. For the test scene, we have a woman arranging flowers inside a flower shop in the early morning. The action is gentle, and the image doesn't change too dramatically. I even added some dialogue to the prompt. The character says one line, and someone off-screen responds with another. This allows us to evaluate the character's movement, overall image quality, audio, and lip syncing. Let's start with Kijai's version. I'm using the 4-step version 0.1 model. Overall, the result looks pretty good. Neither the character nor the movement shows any obvious breakdown. So the main problem isn't the image, it's the audio.
Did these white lisianthus flowers arrive today? They just arrived, still carrying the morning dew.
First, the dialogue specified in the prompt doesn't actually appear as on-screen speech. Instead, all the voices are presented as voiceover. The audio also doesn't sound very clean. It seems to contain some electronic noise. To make the audio problem easier to hear, I generated another version containing only music. Listen carefully. The music gradually sounds as though it's drifting toward the edge of losing control. The second option is larryvrh's version. Following the instructions on the official page, I selected the v50 new by EMA version. The audio in this result is cleaner than the previous one. But once again, the dialogue plays as voice gen over, and the character's mouth doesn't move in sync with the speech.
Did these white lisianthus flowers arrive today? They just arrived, still carrying the morning dew.
Finally, let's look at drbaph's version. I selected the LoRA specifically adapted for the pruned model and set its weight to 0.75. Take a look at the final result.
Did these white lisianthus flowers arrive today? They just arrived, still carrying the morning dew.
The character's movement is relatively natural, and the audio is cleaner than in the first two tests. We can also clearly see the character speaking. The relationship between the lip movements and the voice is much more convincing. After this round of testing, I think the drbaph version delivers the best result. To confirm that it performs more consistently under the same workflow and test conditions, I ran another test in a kitchen scene. Here, a woman is steaming osmanthus cake. Her movements, the steam, the kitchen environment, and the sound all feel quite natural. Listen to the audio.
Yeah. Can we eat them now?
Give them a moment to cool.
This is why I ultimately recommend drbaph's version as the default Turbo LoRA. If your videos mainly involve gentle actions, such as standing, turning slightly, arranging objects, walking, or cooking, I recommend using this LoRA directly. But here's the next problem. Performing well with gentle motion doesn't guarantee that it will also perform well with fast, dramatic action. For this test, a woman on a boat accidentally drops a postcard. The sea breeze blows it away, and a crew member eventually catches it for her. The two characters also exchange a short line of dialogue. The challenge is that this scene contains many actions, and those actions change quickly. Let's see how the four-step turbo workflow performs. First, the result isn't completely unusable. The characters and environment are still present, and the motion is relatively continuous. However, the image shows obvious flickering. So how do we solve that? This brings us to the second workflow. The core idea is very simple, two-stage sampling. We divide the entire sampling process into two stages. In the first stage, we use the standard MiniMax H3 model without Turbo LoRA acceleration. This allows the original H3 model to establish the basic structure and composition of the image. I've also enabled suggestion here to improve the speed. In the second sampling stage, we load the Turbo LoRA and use it to refine the overall image structure. The most important node here is SplitSigmas, which divides the complete Sigma schedule into two sections. The first two steps are used to establish the composition, while the final four steps handle refinement. The first two steps use the full H3 model, and the last four use the accelerated Turbo LoRA. There's one more important detail. During the second sampling stage, you need to disable noise injection by using the complete H3 model to establish the composition. First, we can prevent the flickering we saw earlier. Let's look at the result.
Who is this for?
Someone who has never seen the sea.
With this second workflow, the flickering problem is effectively resolved. It works with both fast and slow movement, and the generation speed is still very good. It isn't quite as fast as the first workflow, but it can still generate a 5-second video in roughly 2 minutes. Further demonstrate the effectiveness of this workflow, I added two more tests. The first uses a dressing room mirror. In the reference image, the relationship between the character outside the mirror and the reflection inside it is incorrect. Let's see whether the model can fix that error. We're still using the same two-stage sampling workflow. In the generated video, the character raises both hands and then lowers them. After this movement, the character and the mirror reflection become consistent. The second test is a scene commonly found in Chinese wuxia or xianxia films, flying on a sword. This kind of movement is quite difficult for a video model. We provide a reference image with a beautiful overall composition, then generate the video. In a scene like this, the character needs to remain stable while the clothing and hair move. The camera also needs to change as it follows the flight. Not every detail in the final video is perfect, but the overall relationship between the movement and the camera remains fairly complete. Generating such a complicated sequence with a 4-step Turbo LoRA is enough to demonstrate both the LoRa's capabilities and the underlying capabilities of the original MiniMax H3 model. In this video, we focused on two workflows. If you mainly generate gentle movement, you can use the 4-step turbo workflow directly. If fast movement causes flickering in your videos, I recommend trying the 2-stage sampling workflow. It's more stable overall. Although it's slightly slower than the 4-step workflow, the balance between speed and quality is still excellent.